friends, after the discussion of the photodiode is connected in reverse bias. The current flowing through the photodiode is due to the minority charge carrier, therefore is in order of microampere. The application of the photodiode is to detect the optical signal, that means as a photodetector. Photodiode is always connected in reverse bias mode. These are the important points of the photodiode. Frequently asked in MCQ type question. Right. After that, we are going to start our discussion about the light emitting diode, that means the LED. How the light are emitted from this type of the PN junction diode. Right. So the question is that explain the construction, working, uses and benefits of light emitting diode. Okay, what is the light emitting diode? Light emitting diode is the heavily doped PN junction. Heavily doped PN junction, that means if the concentration of the impurity atom in p-type and n-type semiconductor is more compared to the average value, at that time this PN junction diode is acted as a light emitting diode. That means in light emitting diode, a special kind of the PN junction is used in which the more amount of the impurity atoms are added. Thus, it is a heavily doped PN junction which under the forward bias. So keep in mind that the LED is always connected in forward bias. Again, the light emitting diode is always connected in forward bias, which emits the spontaneous radiation. Hence, the diode have to provide the forward bias to operate. To get the spontaneous emission of the radiation or the light, it is necessary to connect the light emitting diode is in forward bias. So there is the requirement for the light emitting diode always connected in forward bias. So the spontaneous radiation, hence the diode have to provide the forward bias to operate. Okay. The diode is encapsulated with the transparent cover so that emitting light can be come out and the outline of the LED is shown in the figure. So entire PN junction diode working as a light emitting diode is encapsulated by a transparent cover. So as a result, the light is gathered and coming out from the diode. So the construction of the light emitting diode is shown in the figure. Here there is the p-type semiconductor, here the n-type semiconductor. So heavily doped, that means the concentration of the impurity atoms in p-type and n-type semiconductor is very high. P is connected with the positive terminal of a battery with the load resistance, while the negative terminal of a battery is connected with the inside of the junction. Inside of a junction. Now the symbol of light emitting diode is same as the photodiode, but here in photodiode this arrow is towards the PN junction diode, while in light emitting diode these arrows are coming out from the PN junction diode. So here the outward direction, while in photodiode inward direction. So here the light is emitted from the PN junction diode, therefore the arrow of radiation is outward. That is the symbol of light emitting diode. Okay, how this PN junction diode works? When there is no bias at the junction, the concentration of the minority areas increases, thus at either side of the junction axis minority areas are there, which recombine with the majority charge carrier near the junction. As a result, the energy is released in form of photon. What it says there? When the no bias is connected with the PN junction, what's happening? Here the minority charge carrier in p-type semiconductor are electron, and in n-type semiconductor minority charge carriers are hole. So what's happened? When the PN junction is formed, the electron from the N region to the P region are diffused and hole from P to N diffused. Therefore, in N side, number of the hole increases, while in P side, number of the electrons are increases. Actually, in P side, the minority charge carriers are electron, therefore the minority charge carriers are increases. The same way, in N side, the minority charge carriers are hole are diffused from P to N. Therefore, the minority charge carrier hole in N region increases in absence of any bias. Bias, that means no battery connected. Again, when there is no bias at the junction, the concentration of minority carriers increases. Thus, on either side of the junction, excess minority carriers are there. So here the whole electrons are minority charge carrier. Here the holes are minority charge carrier in N side. Due to the diffusion of electron from N to P and hole from P to N are increases, which recombine with the majority charge carrier near the junction. So here this hole are recombined with the hole with the electron. Electron are the majority charge carrier in N itself. While monadal electron are diffused from N to P. In P side, majority charge carriers are born. Therefore, these electrons are combined with the majority charge carrier near the junction. As a result, the energy is released. Due to the recombination, the energy gets released. There is the concept of the light-emitting diode, and this energy released is in form of photon, that means in form of light. Clear the same? Now, photons with the energy equal to the slightly less than the band gap are emitted. How much energy is emitted or the radiated? Due to the diffusion of the electron from N to P and hole from P to N. So energy equal to slightly less than the band gap energy. What are the band gap energy for this PN junction diode? So this energy is released due to the recombination of minority charge carrier in particular region with the majority charge carrier. When the forward bias current of the diode is small, so when the bias is connected, therefore the current are going to flow. So in this case, the bias current start to flow, and that is known as the forward bias current. And this forward bias current of the diode is small. The intensity of the light emitted is small. The current flowing in this is small. At that time, what's happened? Here the current is flowing in this direction. When the value of the current is small, at that time the intensity of the light emitted is small, and as the forward current increases, so intensity of the light emitted is also increases. Thus becomes the maximum. As the time passes more and more, the hole are flowing in this direction and electrons are flowing in this direction. Due to the forward bias, already we discussed the forward bias of a PN junction. In forward bias of a PN junction, the electric current is formed due to the majority charge carrier, and that is in order of milliampere. Right? Okay. So when the forward bias current of the diode is small, the intensity of light emitted is small, and as the forward current increases, so intensity of radiation increases and becomes the maximum. Okay. Now, further increase in forward current. Once the frequency of the emitted light is maximum, after that the forward current is increased. What's happened? The result is the decrease of the light intensity. Further the increase in forward current, the intensity of the light is decreases. LED are biased so that the light emitting efficiency is maximum. So here the light emitting diode is biased in such a way that the emitting efficiency becomes the maximum. The IV characteristic of light emitting diode is similar to that of the silicon junction diode. Here the characteristic of light emitting diode, IV characteristic, is similar to the silicon junction diode. But the threshold voltage are much higher and slightly different for each color. Now what's happened? The IV characteristic of LED is same as the IV characteristic of silicon junction diode. But the threshold voltage are much higher for light emitting diode and slightly different for each color. The different color of light emitting diode is available in this season. That means in during the Diwali and also the Christmas, we are using the series with the different color. So all these bulbs are the light emitting diode, that means the LED. Here the different colors of the LED are available for different color. The threshold voltages are slightly different. The reverse breakdown voltage of LED are very low, about 5 volt. Reverse breakdown voltage of light emitting diode is very low, that is about 5 volt. Now, LED that can emit the red, yellow, orange, green and blue light are commercially available. The LEDs in the different colors are available. Red, yellow, orange, green and blue lights are commercially available. The semiconductor used for fabrication of visible LEDs must at least have a band gap Eg of 1.8 electron volt. The LED prepared from the material should have the band gap Eg value is approximate 1.8 electron volt, because the spectral range of visible light is 0.4 micrometer to 0.7 micrometer, and that is from about 3 electron volt to 1.8 electron volt. So the spectral range of the visible light has the wavelength is in order of 0.4 micrometer to 0.7 micrometer, and that is from about 3 electron volt to 1.8 electron volt. Right? That is the band gap energy corresponding to the wavelength of visible region. So now we calculate how the band gap energy corresponding to this value we obtain the 3 electron volt and 1.8 electron volt, and also what are the material are used to fabricate the light emitting diode. Before starting this discussion, again we repeat about the light emitting diode. Now the question is that explain construction, working, usage and benefit of the light emitting diode. Now the LED is a heavily doped PN junction. There is also the PN junction diode, but yes, the concentration of the impurity atoms are added is very high compared to the global PN junction diode. Okay. Which under the forward bias, that means the light emitting diode is connected always in forward bias. Hence, the diode have to provide. So what's happened? The spontaneous radiation of the light takes place. So as we connect the PN junction diode with heavily doped impurity atoms is in forward bias, so which emits the spontaneous radiation. To operate this light emitting diode, the forward bias is required. The diode is encapsulated with transparent cover so that emitted light can came out. The outline of light emitting diode is shown in the figure. So this light emitting diode is encapsulated by the transparent cover so that the emitted light can came out. When the diode is in forward bias, the electrons are sent from N to P and holes are sent from P to N, where they are minority charge carrier. So electrons are sent from N to P and holes are sent from N to P to N. Again, when the diode is in forward bias, the electrons are sent from, that means the electrons are diffused from N to P region and holes are diffused from P to N region, where they are minority charge carrier. when the hole reaches to the N region, in N region the minority charge carriers are hole. And what are the electrons are diffused from N to P? When it reaches in P region the electrons are minority charge carriers. When there is the no bias, when the battery is not connected between the P and N end of the junction diode, at the junction, the concentration of the minority carriers increases. So, what are the electrons diffused from N to P and hole from P to N are accumulated near the junction. Therefore, the concentration of the minority carriers increases. Thus, on either side of the junction, excess minority carriers are there. Therefore, in P side, the numbers of the electron increases in absence of the bias, while inside the holes are increases due to the diffusion of the hole from P to N in absence of any bias, which recombine with the majority charge carrier near the junction. As a result, the energy is released in form of photons. So this electron recombine with the majority charge carrier of hole in P region, while this hole in N region recombine with the majority charge carrier electron in N region. As a result, what happens? The energy is released in form of a photon. Thus, the photon with the energy equal to the slightly less than the band gap energy EC are emitted. So as a result, the photons with the energy equal to slightly less than the band gap energy are released or emitted. When the forward bias current of the diode is small, that means when the bias is connected and forward bias current is flowing, the electric current flowing in the outer circuit is from N to P. Right? When the value of forward bias current is small, at that time, the intensity of the emitted light is also small. As the forward current increases, so intensity of the light also increases and becomes the maximum. When the frequency of the emitted light once becomes the maximum, after that, again the increase in forward current. So what's happened? The decrease of the light intensity, the LED are biased so that we obtain the emitting efficiency becomes the maximum. Again, further increase in forward current results the decrease in intensity of emitted light. But here the LED are biased so that the efficiency, emitting efficiency is maximum. No change in emitted light. Okay. The IV characteristic of light emitting diode is similar to the silicon junction diode. Forward bias characteristic already we discussed this way. Yeah. But here, the threshold voltage for light emitting diode is much higher than the silicon junction diode. For light emitting diode, for IV characteristic is similar to the silicon junction diode, but here the threshold voltage is much higher than the silicon. And slightly for different color, the threshold voltage is slightly different. Here the light emitting diode are available in also different color. Some LED emits the red, yellow, orange, green and blue light. So for this type of the LED, the threshold voltage are slightly different. The reverse background voltage of LED are very low, about the 5 volt. Actually the reverse bias voltage is negative voltage, therefore minus 5 volt is small. Actually the 5 volt is very large voltage. But here the reverse bias background voltage of LED are very low, that means the minus 5 volt. The LED that can emit the red, yellow, orange, green and blue light are commercially available. The semiconductor used for fabrication of visible LED must at least have a band gap Eg of 1.8 electron volt. Right? The semiconductor used for fabrication of the visible light emitting diode must at least have the band gap energy is in order of 1.8 electron volt, because the spectral range of visible light is in order of 0.4 micrometer to 0.7 micrometer, and corresponding to that the value of the band gap energy is from 3 electron volt to 1.8 electron volt. Clear this thing? Okay. And due to that reason, to prepare the light emitting diode which emits the visible light, the material used should have the band gap energy is in order of the 3 electron volt to 1.8 electron volt. Clear this? So, corresponding to this wavelength of a visible light, how we obtain the band gap energy 3 electron volt and 1.8 electron volt, we are going to discuss, and which material are used to fabricate the light emitting diode with which emit the different color. Now just to discuss about that, the wavelength of visible lesion is 0.4 micrometer to 0.7 micrometer. Now corresponding to this wavelength, what is the band gap energy for this semiconductor? Now using this expression, Ez is equal to Hc upon lambda. Right? Therefore Eg1 and Eg2 we are going to find out. That means 3 electron volt to 1.8 electron volt. Already we discussed, that is the energy gap corresponding to this wavelength. So here Eg1 is equal to Hc upon lambda 1. Therefore substitute the value of H Planck's constant 6.625 into 10 is to minus 34 into C, velocity of light in vacuum 3 into 10 is to 8 upon lambda. Lambda is the 4 micrometer, that means the 4 into 10 is to minus 7 meter. There is an electron volt to convert into the there is in SI system convert into the electron volt. Therefore we have to divide by 1.6 into 10 is to minus 19. Therefore we obtain the 3.1 electron volt. Therefore the energy gap corresponding to the wavelength 0.4 micrometer is 3.1 electron volt. Now the energy gap corresponding to the wavelength 0.7 micrometer is Eg2 is equal to Hc upon lambda 2. H is the Planck's constant 6.625 into 10 is to minus 34. C, velocity of light in vacuum 3 into 10 is to 8 upon lambda 2, 7 micrometer, that means the 7 into 10 is to minus 7 meter. Convert into electron volt, we have to divide by 1.6 into 10 is to minus 19. Therefore we obtain the 1.774 electron volt, therefore 1.8 electron volt. So whatever the light emitting diode should have slightly less than the energy gap, and its value is approximately the 1.8 electron volt. Right? Therefore, for visible light emitting diode, the energy gap must be lies between 1.8 electron to 3.1 electron volt, corresponding to the wavelength of visible lesion 0.4 micrometer to 0.7 micrometer. The compound semiconductor. Now, the LED are prepared or fabricated from which material? Right? the compound semiconductor gallium arsenide phosphide GaAsP is used for making the LEDs of the different colors. LEDs are prepared from this type of the semiconductor gallium arsenide phosphide. Right? The proportion of the gallium arsenide and phosphide are different. As the phosphide is X, therefore gallium arsenide is 1 minus X. That is the proportion to making the LED with the different color. Now, gallium arsenide 0.6 and phosphorus is 0.4. Therefore, the band gap energy for this semiconductor is 1.9 electron volt. Is used to prepare the red emitting light LED. That means, as you take the proportion of the gallium arsenide 0.6 and phosphide 0.4, corresponding to this semiconductor, the band gap energy is 1.9 electron volt. This material is used for red LED. Okay. Now, gallium arsenide phosphide, having the band gap energy is 1.4 electron volt, is used for making the infrared LED. Generally, in our remote control of our TV, CD player, and most of the all remote control, we are using this LED. That means the infrared LED. For this type of the LED, the band gap energy is 1.4 electron volt. Now, the use of the LED are in remote control, burglar alarm, that is for prevent the stealing and optical communication. Generally, the application of the LED in remote control, alarm, and also optical communication. The LEDs have the following advantages over the conventional filament low power lamps. In past, we are using the electric bulb having the filament, that means the yellow bulb. Right? So what are the advantages of light emitting diode over this type of the filament bulb? First is the low operational voltage and less power. LED consume or require the less operating voltage, and also the power consumed is also less compared to the filament bulb. Second is the fast action and low warm-up time required. So here, as we switch on the spot, the light is emitting from the light emitting diode. No warm-up time is required. While in filament bulb, as we switch on, so intensity of the light is initially less. As the time passes, the more light or the high intensity light is emitted because it requires some time to warm up. The bandwidth of emitted light is 100 angstrom to 500 angstrom, or in other words, it is nearly monochromatic. Whatever the light is emitted by the light emitting diode is in order of wavelength 100 angstrom to 500 angstrom. That is in order of monochromatic light. That is made up of the single wavelength. Now, the long life and ruggedness. So, that is working for the long time, and also the band of in our language. Right? The long life and ruggedness. The fast on-off switching capability. So these are the benefits of the light emitting diode over the filaments bulb. Again we repeat, we discuss about the wavelength of the visible region, 0.4 micrometer to 0.7 micrometer. Corresponding to this wavelength, the band gap energy is 3.1 electron volt and 1.8 electron volt. Okay. So which type of the material the light emitting diodes are preferred? So the compound semiconductor gallium arsenide phosphide GaAsP is used for making the LEDs for different color. The proportion of the P X at that time, the proportion of the gallium arsenide is 1 minus X. Like as the gallium arsenide 0.6, phosphorus 0.4, band gap energy is 1.9 electron volt. Is used for preparation of the red LED. Now, gallium arsenide phosphide having the band gap energy is 1.4 electron volt is used to prepare with the fabricated the infrared LED. The use of the LED are in remote control, burglar alarm for prevent the stealing, and optical communication. What are the benefits of the LED over the filament bulb? The LED is low operating voltage and consumes less power. Second is the fast action and low bulb time is required. Third is the bandwidth of emitted light by the light emitting diode is in order of 100 angstrom to 500 angstrom wavelength, or in other words, it is nearly monochromatic. And long life and ruggedness, and last is the fast on-off switching capability. So that is the brief history about the light emitting diode. Now we are going to discuss about the solar cell. What is the construction and working of a solar cell?